This is equation 13.6, where we look at Newton's second law in cylindrical coordinates. So that's what we have here with these three equations, which are on your equation sheet. Just remember that when you need to know what a component of the acceleration is, you can go back to what we had in chapter 12. So in this case, you'd look at equation 1232 to find the radial, the transverse, and the z components of the acceleration. We do have one additional equation for this section, which is equation 1310. You should read through these 2 pages on your own where they talk about this equation. So the equation that we have here, equation 1310, is to find this angle psi. What this angle is the angle between the extended radial line and the tangent line. So remember, for cylindrical coordinates, well, if you're only in 2 dimensions, it's actually just polar coordinates. So you have the radial direction and the transverse direction. The radial direction goes from the origin to the location of the particle, so you're going to keep drawing that line past the particle. That gives you the extended radial line here. And the tangent line is tangent to the path of the particle, so the angle between the extended radial line and the tangent line is the angle psi. Now, this angle, the way that we measure it, is going to be no greater than 90 degrees. So, let's see, if you look at figure 13.8, they're measuring that angle in the clockwise direction from the extended radial line to the tangent line rather than in the counterclockwise direction like what we have here. So when you put this into your calculator, remember that your calculator should give you something between negative 90 degrees and 90 degrees. So if you get something, or when you do the inverse tangent, that's what you would get. So if you get a positive angle, that would be in the counterclockwise direction, and if you get a negative angle, that's in the counterclockwise direction. So make sure you read through this on your own, and you will see how that works in some of the example problems.